Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Daniel Faruqi bin Roslan and my metric number is CN220090. Thank you.
Hi, my name is Dicky Tan Sing Yao and my matrix number is AN220158.
Okay, my name is Muhammad Nasim bin Sulaiman and my matric number is CN210203.
Assalamualaikum. My name is Siti Saira binti Saiman. My metric number is CN21004. I currently on my third year study in UTSM. My course is Bachelor of Engineering Electronic Technology in Industrial Automation. Thank you. Hello, I will present about objective of IDP. The objective is to design and program the control system for a two-axis Cartesian robot that can pick up objects from one location and place them in another location. The robotic system will utilize pneumatic cylinder for linear motion along the X and Z axis. Thank you. Next is design statement or engineering problem. There are two design statement or engineering problem. The problem number one is design, compile, simulate, transfer, and analyze the PLC programming for the engineering problem using CS Programmer versions 9.57 software and Auburn CP1E PLC. Suggest possible PLC programming for the system that comply with 1E61131 standard, either using normal latching, keep, set, reset, diffuse, DIFD, move, increment, decrement, or CMP instruction. The next problem is in the electrical pneumatic circuit, we cannot use limit switch sensor because two-axis robot pneumatic in the lab use proximity sensor, which is we have to change the connection of the circuit from limit switch sensor to proximity sensor. The function of proximity sensor is to generate an output signal when opposing magnetic field or ferrous material is within sensing distance of the two-axis pneumatic robot. That's all.
So for the experiment setup, from the figure 1.1 you can see the two-axis pneumatic robot. This robot has four sensors, which is the up sensor, down sensor, left sensor, and the right sensor. Each sensor has different address. From the up sensor, the address is 0003, down sensor is 0004, left sensor is 0002, and lastly for the right sensor is 0001. For this project, we have to create program using CS Programmer and upload it into the CP1E and 20 PLC. Next is the process of the axis robot. When push button is pressed and released, the down sensor goes down and the ungrip arm is at ungrip state. After 3 seconds, the grip arm will grip the object from point A and the up sensor is energized to go up. After the arm went up, the right sensor is energized and without any delay, the down sensor is energized again to go down. After 3 seconds, the grip will open and drop the object picked from point A to point C. After releasing the object, the up sensor is energized again and will move to its initial state, which is at point A. This robot will continue this cycle for 10 times. In figure 1.2, this is the HMI PLC kit trainer. At this kit trainer, you can see the PLC CP1E N20 and the input and the output. The input is connected to the axis robot according the address of the robots. And the output is connected to the output of the axis robot.
Okay, my name is Muhammad Nasim and I'll present for the ladder diagram using six programmer. Okay, for the first round, we have a relay 1 using keep instruction. The function is to start and stop the operation of the system. Also, a counter C00 will also stop the operation. For the rung 1 is the operation of the left arm and up-down arm and the grip. From there, we can see that the left arm is controlled when the stop switch is activated or counter conversion is done or when to return to the left position after the 1 cycle. Next, the up-down arm is activated when the right sensor and grip is activated. For left sensor and timer T00 is activated. Then the down sensor are used to activate the grip, which uses the set instruction. Okay, next is round 2, which has a timer when the grip is activated for 3 seconds, X box A. Then we have a right arm control which activate at the up sensor. Then for the round 3 is a timer when reaching the box C. The timer activate when the right sensor, grip sensor, and down sensor are activated at the same time. The timer is for 3 seconds. Okay, for the next round is round 4. We have a reset instruction for grip, which is turned on when either the stop button or counter completion or timer T01, T001 is on. The reset instruction will release the grip. For the round 5, we have a counter to count until 10. It counts when the timer T001 is activated, which on the system is after reaching the box C and going up, releasing the up-down arm and grip. And the reset counter are controlled by the stop switch. And for the last round is the timer when the arm is at right position and up position. It will wait for 5 seconds before going to left position or initial position. The timer is T002. Okay, that's all for the explanation of the ladder diagram. Thank you.
So for the electro-pneumatic circuit explanation, we design the circuit by using fluid sim application. In electrical circuit, we use push button, relay, valve solenoid, proximity sensor, switch on, delay timer, and counter. And in pneumatic circuit, we use double acting cylinder, 5 3-way solenoid valve, 5 2-way solenoid valve, air service unit, and compressor air supply. So first, in electrical circuit, when the push button PB1 is pushed, the current flow from 24 DC power supply and the relay KF1 is energized. The normally open contact relay KF1 will close, lead to the energize of valve solenoid MB1. In pneumatic circuit, a magnetic field is produced in coil MB1. Then activate left switching position. Port 5 is blocked, it compress air freely flows from the compressor to up-down arm through port 1 to port 4. The compressed air is in the cylinder, then exhausts from port 2 to port 3, and the up-down arm will advance. When the end of the up-down arm reach the limit, the down sensor will get actuated. And when the end of the up-down arm reach the limit, the down sensor will get actuated, and the current will flow through relay KF2. The normally open contact relay KF2 will close, lead to the energize of valve solenoid MB2. In pneumatic circuit, the grip will advance. Then the switch on delay timer T0 will activate due to the current flow through it. Then when the time set 3 seconds is passed, the normally open T0 will be closed. Then let the current flow to energize relay KF3. The normally closed contact relay KF3 at node 3 will open, and the valve solenoid MB1 is de-energized, and the up-down arm in pneumatic circuit will be retract. The grip is still extending because the normally open contact relay KF3 and node X is still open, and let the current continue to flow through the MB2. When the up-down arm is retract, the up sensor is actuated. The current flow and the relay KF4 is energized. When KF4 is energized, the normally open contact relay KF4 at node 13 is closed. The current flow to node 13 and relay KF8 is energized. The normally open contact relay KF8 at node 15 is closed, and the valve solenoid MB3 is energized. In pneumatic circuit, the left-right arm will advance. When the end of the left-right arm reach the limit, the right sensor will get actuated and the relay KF5 is energized. Then when the normally open contact relay KF5 at node 4 is closed, the valve solenoid MB1 is energized, lead to the advance of up-down arm. Then the switch-on delay timer T1 is activated. When the time set 3 seconds is passed, the normally open T1 will close. Then let the current flow to energize relay KF6. The normally closed contact relay KF6 at node 4 and node 7 will open, lead to the de-energize of valve solenoid MB1 and MB2. So the up-down arm and grip will be retracted. The normally open contact relay KF6 at node 20 will close, lead to the activation of switch-on delay timer T2. Later, when time set 5 seconds is passed, normally open T2 will be closed, lead to the energize of valve solenoid MB4. The left-right arm will go to its initial position, and this process will repeat 10 times unless push button reset is pressed. This is because current will flow through R1 and R2, which is reset button, and the preset counter will always repeat the process. Finally, when one cycle and new cycle has started, the number at counter will decrease by 1 until the process had repeated 10 times.
Okay, for the discussion of our group, from our observation when constructing the electro-pneumatic circuit, we did face a lot of difficulty, like when we had to troubleshoot error, like when grip and the up-down arm retract at the same time, which made the process of the assist robot not accurate. We have to identify where to fix this error at, so that up and down arm and grip has a gap of 3-second delay. Furthermore, we also did have an error where the left and right arm did not have a delay of 5 seconds before moving back to its initial position, which is on the move to point A. When the counter reached 10 and reset back to 0, we have to add a delay timer at node 15 so that the left right arm has a delay of 5 seconds for moving back to its initial position, which is on the point A. Okay, for the PLC, one challenge with programming the PLC for the system is managing the complex sequencing of all the sensors and actuator with multiple limit switch, cylinders, and other components. Coordinating the precise series of operation can become complicated. Overlapping action or interference between steps can lead to unexpected output or malfunction. Tracing through the logic rung by rung may be required to troubleshoot, while the actual performance does not match the intended sequence. Okay, that's all for the discussion.
For our conclusion, that we can conclude this project successfully developed a 2-axis Cartesian robot system to automatically transfer objects between places. The PLC controls program precisely coordinated the pneumatic cylinders, limit switch, and the gripper to execute the pick and place sequence. Despite all the challenges, managing the complex multi-step logic, incremental testing, and simulation enables proper sequence of the movement. That's all.